SunTrain is developing innovative battery freight trains that will deliver gigawatts of clean power to undersupplied load centers using the existing railroad network. Our approach utilizes existing fossil fuel railroad infrastructure and pivots from freight trains hauling coal or oil to trains hauling stored renewable electricity. SunTrain technology leverages customized off-the-shelf equipment that is already in mass production, ensuring the reliability, safety, and scalability of our process. SunTrain is finalizing a $125 million pilot project with a major utility, which will feature a daily 384 megawatt-hour battery train, which will regularly transport renewable energy from a congested rural area to an urban center, reducing the need for natural gas peak power. However, utilities aren't the only organizations curious about SunTrain. Our unique energy delivery method has drawn the attention of developers across North America, who have entitled projects with indefinite delays because the local utility is unable to provide electricity to support new operations. These utilities regularly provide estimates with decade-long wait periods, if they are able to provide an estimate at all. In particular, SunTrain has been approached by numerous developers looking for grid-alternative energy sources to support the critical infrastructure necessary for the ongoing artificial intelligence and data center boom. So, how can SunTrain reliably deliver energy by rail to data centers and similar energy-intensive industries, while the local utilities build out their conventional transmission infrastructure? To do this, SunTrain relies on the proven railroad logistics that kept nearly 1,500 coal power plants operating around the clock during the heyday of coal consumption in America. SunTrain would implement a microgrid with a long-duration battery energy storage system. This system would be SunTrain compatible, allowing a single SunTrain to directly offload up to nearly 2 gigawatt-hours to the facility's stationary batteries. The delivery of energy from SunTrain's railcar-based batteries to the facility's centralized energy storage system allows the microgrid operator to stockpile electricity in the same manner that coal power plants stockpile significant amounts of coal in the event of a supply chain disruption or other unforeseen events. Additionally, industrial-scale solar and/or geothermal systems would augment SunTrain's delivered energy, thus providing the grid-independent facility with 4 different energy sources to keep operations running 24/7. Here's a brief overview of how SunTrain's technology works. Using North America's extensive freight railroad network, SunTrain will coordinate deliveries ranging from just a few railcars to full unit trains of 100 railcars or more. SunTrain can charge from renewable resources such as utility-scale solar arrays, wind farms, hydroelectric dams, and geothermal systems, as well as more traditional grid resources like coal power plants, nuclear generating stations, and electrical substations. SunTrain uses an automated robotic system to quickly and safely connect to each battery railcar. The connection pin adjusts for railcar alignment, enabling efficient energy transfer of 5 megawatt-hours per robotic unit, allowing 20 megawatt-hour battery railcars to charge in as little as 4 hours. An AI-powered battery management system optimizes charging for safety, durability, and lifespan, while also monitoring safety sensors to ensure proper functioning during both operation and railroad transportation. After charging, railcars are moved to their discharging location. Each battery is individually equipped with fire suppression systems for added safety in case of derailment or system issues. However, SunTrain's iron and phosphate batteries, made from stable, non-toxic, non-explosive elements, which rank as the 6th and 16th most abundant minerals on Earth. This remarkably stable chemistry is unlikely to encounter thermal runaway even in the event of a catastrophic derailment. At the discharge location, the robotic energy exchange systems enable simultaneous discharge of all battery railcars. SunTrain provides end users the flexibility to power electrical loads, recharge a critical AI facility's on-site microgrid, or even feed energy directly into the local utilities grid. Class 1 railroads and even most short lines will serve facilities 7 days a week and may serve multiple times per day depending on individual end user needs. SunTrain's core technology and supporting systems are currently in mass production and available for demonstration at the Testbed Rail Yard in southeast San Francisco. SunTrain can rapidly mobilize a full-scaled unit train operation in as little as 12 months. There's no shortage of existing infrastructure from which SunTrain may source its energy. There are thousands of electrical facilities nationwide that are already rail-served, which are easily adapted to charge SunTrain batteries. Coal power plants, natural gas power plants, major substations, wind farms, solar arrays, and even hydroelectric dams and nuclear power plants are all examples of existing systems that frequently have rail service or adjacent railroads. Many of the aforementioned facilities either receive trains carrying raw materials to be converted into electrical energy, or these facilities were built with components delivered by the local railroad. The freight railroad network powered the Industrial Revolution in America. With existing technology and proven logistics, the railroad industry can provide the backbone of both the green energy revolution and the artificial intelligence economy.